Thanks everyone for having me. This feels a little odd because I have no DevOps background whatsoever. I'm mostly interested in like large-scale analytics, but have been trying to get closer and closer to real-time data as I've bounced around through jobs and found that monitoring and real-time data has been super interesting. So this talk is a little bit of like my perspective about how DevOps works with the rest of the company, what DevOps can teach the rest of the company, how it can communicate better with it, and how other parts of the company can learn from DevOps as I've sort of learned in my experience. So just tiny quick background. Let's see if this clicking works. Yeah, OK. So I'm Jeff Weinstein. I just really love data and have been interested in large-scale analytics for a while. Just mostly the first job at Comscore was just exciting to see so much data, a lot of data on people in the room, and data about everybody else. And it was really exciting to learn about large-scale data operations. And then went to a small startup that ended up getting acquired by Groupon and have just been interested in how real-time data can improve the company and all companies. And this talk will be, I think, really helpful to people that work at fairly large-scale companies, but hopefully will be helpful for people who work at smaller-scale companies too. Yeah. So, I've been most of the people on the top a little bit in prior roles, and I've always been curious, like, what is DevOps? Like, how does it work? If I've written code and I used to be one of those people who want to just throw it over the wall, and then got interested in what happens in production, and I've been really interested in data science and business intelligence, and then had opportunity to run the show a little bit, try to understand data from a higher perspective. And now that I've been at a large company, I see that DevOps touches all of these pieces, but not always directly and not always in a great way. So we're going to sort of walk through how DevOps can improve the relationship across these groups and use the data that's available through DevOps to make for better experiences. So first we'll walk through a little bit about where is DevOps in the organization, and then what types of problems does it cause, and then a few specific things that you can do to try to solve those problems either through code or through communication. So from my naive top-down view, this is where I sort of see DevOps if you just blow up the picture for a second. The rest of the company might be coming up with the products and the plans and the code and the configuration of what needs to happen. And DevOps, at one extreme is responsible for the performance and the stability and the change and the release management that comes out of those things. And other companies, it's more of a hands, the DevOps is closer knit to these other pieces. But the primary responsibility that I've seen for people on these types of teams is let's make sure the apps and services, the actual production things are running, we understand it, and we want to get the data that comes out of it, and the general role is let's keep things in the green box going great. The rest of the company is sort of a little bit outside the box sometimes. And those responsibilities have made DevOps have to be experts in certain areas. And this is a lot of it's from a data perspective. But if you're focused on these areas, you're going to develop your own tool set. You're going to develop your own best practices. You're going to develop your own teams. You're going to develop your own culture around these types of problems, because these are real complicated problems. We heard in the prior talk, just how any little piece of this can go awry and cause major issues in production. None of these things are simple. So these responsibilities have led for great understanding of what's going on in our production systems, but they also lead to some larger problems. So one of the problems is within the organization, right? DevOps is in a somewhat precarious role some places where you're between engineering and operations. You might be between product and engineering, where you have to control either schedules or production releases or the policy around them. From an organization perspective, there is a built-in natural tension between reliability and change, right? You always want to be pushing new things. You want to be able to iterate quickly. That can be part of your culture, but it might also run into tension when you have for larger companies, you might have an earnings call coming up, or you want to get through a holiday cycle without issue. There's these balances to be had, and DevOps is right in the middle. So you could be great at your job in DevOps, but still piss everybody off. So that's a hard part in the organization. There's also a question of like how involved should DevOps be like in the product planning, in the development cycle, in the capacity planning, in the how is this going to affect our other production systems. The further you are away from it, the more flexibility the rest of the company has, but then you might be blindsided. But if you're too far into it, then it might affect the planning. There's a natural balance to be had here too, which is complicated. And because DevOps has lots of these responsibilities that to some people in the company are they're shielded from, right? Like there are some people in our companies that think everything comes for free, things run perfectly all the time, and any errors or blow-ups is a mistake or shouldn't have happened, or it's because we're bad at something. But those in the know recognize that it's almost a small miracle that any of this stuff works whatsoever, and the fact that these things break is like part of the lifeblood. We just have to be good at getting better at it. So because it's a little bit hidden and sort of dirty from where the budgets are, it's often underinvested in. Probably if you ask anybody on any team ever, they'd say it's often underinvested in. And lastly, because they're like the first line and the last line of defense, there's an on-call churn, which has been talked about a lot. People can have lived it harder than I have, so I won't lecture on that subject. But being responsible for the code and the production operations of a system that you sort of control and don't control and have a lot of tension on puts you in a tough spot in the organization. So that's like one of the issues that's going on. Another set of issues is that we've built these like data silos of for the same actions and on the same data. So for DevOps, in some ways you're creating a lot of your company's data, like you're birthing it, you're collecting it, you're forwarding it, you're aggregating it, you're counting it, you're moving it around, you're sampling it. And there's lots of systems. It's just a small list of these things here for, how do you do it ad hoc? What's your storage for it? What's your visualization tools? What's your alerting? And the rest of the company has the exact same problems, and it's often the exact same data, and they have an entirely different stack for it. So this is another reason why there's like a natural sort of chasm between these groups, and they have different definitions for things. You can ask for one count in one system, and it's understandably different than it is in another, but people will say, oh, why aren't they exactly the same? One system is streaming and wants to process the latest data as quick as possible, and a burp is okay. The other one, an hour delay or a day delay is fine, but it's got to be correct. There are natural differences in these silos, but they exist. And the technical skill set between these two data silos is also extreme. I mean, Excel is listed twice on this other side. Excel's probably in every single one of these categories on the right-hand side. I've never seen it on the left-hand side. So there's just another natural barrier here. And there's also a understandably large focus on machine metrics, right? The boxes are making the thing go, and you need to watch their core inputs and outputs. But this looks crazy to people who don't care about it. Like, they should care about it. We should probably teach this in kindergarten-ish. But if you probably all had this. You could be proud of like this massive graph that loads per host, and the templates work for all clusters, and you can dive into each host and see its CPU and all aggregates to the top and pat yourself on the back. And you show it to someone who's outside the system, and they're like, yeah, it was slow on my phone, so I don't care. So this is another place where like DevOps, it's kind of a different world. Then there's this whole problem where the views, they're not bad, they're just bad. They're bad, and you've done a good job. I mean, I made all of these, and they had purpose at one point, and they really did. But you can show the wrong thing to someone, and then they'll just say that whole tool, that whole stack, like that's not for me. Like keep that on the other side of the dungeon, and I'll wait for the outputs to be ready tomorrow. But it is the data that's being produced, and we should build tools that DevOps can use to accomplish their tasks, but the rest of the company should use to be able to get the same information and give the right context and right views to the right people. We also have divergent data paths for the same data. So we have all these things that are producing data. They generate like logs. What else are they supposed to do? And then the question is, well, DevOps is interested in the streaming data and making sense of it as quickly as we can to be alerted of outages. I mean, getting to 0-second real time for some of our monitoring is like absolutely critical. Where BI for business intelligence or for some other reporting, they want to put it into a cold storage place and do an ETL on it and put complicated business rules and rigorous definitions and do a bunch of sessionized things that take a longer period of time and require a larger data context to run. It's a perfectly reasonable thing to do, and it's generated an entire different data stream of the same data. Like these things, you can ask the same question to either data stream and get like roughly the same answers if you've meticulously done the definitions of all of your events in whatever language is necessary to execute them on these two systems. And there's no silver bullet to this problem. Like all the teams have different needs. Like this is a purposely complicated looking set of lines. I don't mean your eye to go follow them and see what's what. Like, but what's interesting to me is that the log data that's being generated from your applications and your developers and third-party systems that you're reading from is going through these two same paths, and some of it stays in logs, and some of it's aggregated to metrics by hour, day, week, month, host, service, whatever, right? There's some time series metrics being generated. The same thing happens in batch, and there's lots of uses for it, right? Engineers want access to everything. Like, give me access to everything. I owe it to myself to know where everything is. Like, that's a good attitude. And BI only is interested in generating like metrics from batch data. Data scientists want raw logs to run their algorithms over on top of. They want to be able to see the metrics as well as the raw information. Executives want to be able to see the true metrics of what's happening. But I mean, if you've ever asked anyone in your company, like, would you like more real-time data? They'll always say yes, right? So they are also interested in real-time metrics. And so there's these many needs, and there's these two pipelines that end up being generated that don't share any of the same context. And I find that to be an issue. But like, is this, like, in general, is this good or bad, right? I think it's a very reasonable question. It isn't to say that this whole area of DevOps has gone off the rails in some ways by creating all these tools for themselves. You have built specific tools that like do great jobs at what is necessary to do. It's a complicated problem. We're making a lot of development on it. We've created like decentralized groups, which is good for attracting the problem with focus and ownership. These are great things, but there's the downsides that we talked about, where you lose the context of what's happening, between one group and another. You're siloing the work, where if improvements in your monitoring system only help your team, I mean, there's an externality that happens that lifts all boats about site performance, but you're not helping other people in their day-to-day activities directly. People are in this like data dark that I find comes up all the time, where someone will say, oh, I really wish I had like X by Z and Y, and I want to count that. And I'm like, yeah, I have this like real-time graph for it. They're like, well, like, how do I use that? I can't use that. And so you have teams that have access to data that's important to them, and other teams that who want access to the same thing, and they like put their hands up. So that's a huge issue. And then there's a misunderstanding between teams that happens in organizations all the time, but like is coming through a bunch of real systemic reasons between what's happening in DevOps and the rest of the company. So I have a few little solutions. There are no silver bullets. Some of them are fun stuff that you get to build, fun stuff that you get to buy. Some of it's just how to interact with people and understand where they're coming from. So I figured we'd just spend a few minutes and walk through them. So the build stuff piece, the build stuff piece. One that I've had a lot of success with, that we've had a lot of success with at Groupon, is trying to move our most important metrics and all of our metrics, if possible, to structured logs. So having a defined log structure that has like name, scope, and everything for the entire company that developers can log to, and that structured log gives us the ability to put schema on it pretty quickly. So we can have a developer log something. They just log whatever they want in this format, and they can just drop a config file for that data stream. Doesn't need to be all the keys. It could just be some of them, and say, hey, like, this key is really important, and it's of this type, and this key is of I'm going to talk about the keys in the next slide, but we allowed them to give schema early, and then we can use that schema to generate automatic views, generate statistics, use it to like create a glossary of the data, so you can go to like one place and see all the things that are logged and their definitions that people have put in. We've also built an API on top of our real-time data so that our graphing tools like call through an API, which allows us to say to the rest of the company, hey, if you want access to the same data, like you can use the API that we built our monitoring tools on top of, which is another way of like making the rest of at least the engineering organization have access to the same things. Just little things like being able to annotate and tag metrics or a graph or a time period, and this is across many of the third-party tools and maybe lots of the homegrown things, but you should be able to say, hey, there's an outage, or pipe the outage information, or push the push information, or other types of things into the data sets. And the last one is taking control of your whole data pipeline, and that's like some team should be responsible of, hey, if you log in this format, it's going to go to these places, you'll get this information, and then it'll be available in long-term storage in this location, and have that be a part of your platform as you grow your company, rather than like individual teams just doing their own type of log analysis. I think it's worth doing even when you're pretty small. So I just want to focus on a few of these things that we found to be really interesting. The one is this, as I mentioned, is this structured logs, and then being able to like check in a schema about the log. It's optional, right? If you pipe in logs that don't have this, no problem. Like you can go get access to it later. But if you give us this extra information, then our systems will be able to take that and be able to do some cool stuff with it. So we have like we just pick some serialized format. We have libraries that like you're writing some Node app, like we have a Node logger, a bunch of bindings as you'd imagine, and it will log in the right format and forward correctly. And then you can go and put like different tags in the schema. So you could say, hey, this is like of type date, right? Like date is helpful for knowing down the line that this is a date time field, so we can do interesting things with it, like group them into months or quarters, whatever. We allow people to tag a metric saying, hey, this is latency. And when you tag this is latency, boom, that metric like gets a millisecond view in a log scale, and it's stacked. And as you'd expect for latency metrics, you can just tag your metric as latency, and then you can get access to the view in a cleaner way. We also allow just like a human readable description. Like it's just driven me crazy to see some log file and been like, I can't reverse engineer what real thing this is in the log. It's some stupid key name and some stupid key value that someone did God knows how long ago. What would be great is someone took 10 seconds and wrote one human sentence about, hey, like this is the event when you hover over this button. Like that would help me a long way. So we said, okay, great, just have them be able to put it in, and then we can surface that piece of information in all of our tools down the line. And people can like go ahead and go through our data glossary and see what that key actually means. And then you can also set things like, oh, we only care about this metric for an hour, a day, a month, and we allow people to put that information right into the schema, and then we can pick it up later for our long-term storage or our real-time storage to know other properties about it. And we could add ones later. We actually haven't implemented all of these, but these the types and the tags are really helpful. So then once you have that information, you can automatically like generate a dashboard of all the things that are from that same data stream, and you know roughly what the graph types should be if they've labeled them properly. Our graph tools allow you to like do a quick wildcard, and anything that has like that matches a wildcard generates a new graph. Like little things like this can go a long way in making it easier for developers, for logging, and for everyone for understanding. Once you have those informations, you can automatically generate statistics for these things. So if you expect like if we label like funnel steps like 1, 2, 3, 4, like you can generate the conversion rates between the steps automatically based on that schema. And it's super helpful for like batch analytics and long-term storage, because people who aren't involved in logging can go and say, hey, this data stream is actually this thing based on the schema. I mean, self-service charting tools, like obviously the people in the room should either pick third-party things that are great or build their own things. We are currently in the RRD world of an RRD tool for generating these graphs, and we've done some work to like allow people to quickly just change some of these things, and that's been just helpful. But I think the biggest one is like trace back to source. Like you're looking at a graph, you like look at some line, and you're like, hey, like what logs are actually generating that line. Because we have the schema that knows what was logged, we can say, hey, this log was actually was logged from this application, and this developer wrote this description of it. Gives you a lot more context about it quickly. Okay, so just in the last few minutes, I want to talk about how we DevOps can work with these different pieces, different groups in the organization, and I've broken it into what can we build, what can we learn from them, what should we communicate, and what can we inspire of them to improve their job, learn things from our operations to help them see the light in something new about their business. So for engineers, we should be building and making available logging toolkits that make logging dead simple. We've heard this a lot, but it's something that it should be a go-to thing to how to do log forwarding, how to get information back from client-side applications and JavaScript on people's machines and iOS apps, everything else. We should also be building the data pipeline, these automated metrics. It's so refreshing to be able to log and then just go to some URL and start seeing the graphs without any config, and they already know, this is latency, so it looks great. That goes a long way. What we should learn, at least this is for me, I can't speak for other people in the room, but just more and more technology skills from engineers about automation and how to understand what's happening in their code and what libraries they need in order to log correctly, and hear from them, what do you think the causes of outages will be in the future? What do you think the performance problems will be, so that we can try to build in the monitoring to detect those things earlier, and having that conversation as new products and as new features are being developed rather than later, I think is pretty helpful, because they're probably working through the problems that they're worried about when they're building it. It's a good time to hear from them. Obviously, deployment practices and escalation playbook is huge. We should be communicating to people, hey, what are the top 5 things that you think could go wrong? What if we saw 5 things that make you sleep better at night? What would they be? Let's make sure those are monitored, and we have one-step escalation and build that in directly into the alert. Those things go a long way. And then, what can DevOps do to inspire engineers? Let's make measurement part of test-driven design. It's been said before, but it's if you can build in the monitoring, already have the graphs while it's in some kind of production, in some kind of a development environment, or getting 1% of traffic or whatever it's doing, and watch all of the metrics about your service as part of the testing process, then going into production will be much easier. You're already looking at the monitoring. You already know where to turn. Launch day isn't the first day that you're watching the metrics. It's just another day with a lot more traffic and probably a lot more problems. And obviously measurement prior to production, just push it as much as you can. For BI, oh man, structured logs make their lives a whole world easier. They don't have to write crazy regex ahead of time to start getting stuff out of your logs. It makes for automated ETL possible. Say, hey, listen, if we already have the schema and you already know the data types and you already know the storage requirements, let's just build some hourly scripts that get them into large-scale databases. What should we learn from BI? At least in our organization, and I've seen other large organizations, BI is much closer to the business problems about what is exactly the definition of certain events and which ones are worldwide or US or whatever the situation is. We should be learning from them what the true definitions of these events are, so that we can take those definitions and build them into our real-time monitoring, since they require different sets of they require different sets of configuration. And what slices and visualizations are people already looking at we can mimic in real time? This has been a big one for us. Is what should we communicate? DevOps gets a first look at the data being generated, and that ends up going to BI. So we should alert them about when data size changes rapidly, or the cardinality of some key goes from 10 to 10 million, and it's going to screw up some of their load process or their skew in their database systems. They shouldn't be blindsided by the data that's coming through our systems. We should be testing and sampling it and then communicating that to BI, so they get an early jump on what the problems they might be facing are. Same with outages and delays. Again, I remember querying some database system, being listen, Tuesday has a quarter of the data. What the hell is going on? This is ridiculous. And they're oh, okay, let's check the logs and go back. And then they realize it's some outage that the DevOps team already put out the fire for 5 days ago, for three or 4 days ago. And they're completely they're dumbfounded that there was even an issue. They loaded whatever data was available, like that is truth. So communicating those things upstream is really helpful. But like typically BI has had they mostly use third-party tools. They're fairly rigid. No one likes using them. I can't really think of a good one. And so DevOps has the engineering capability to build awesome interactive tools and visualizations and teach that kind of flexibility and rapid iteration in terms of development process. We should be inspiring them to do the same. Data science, I was scratching my head a little bit about how data science and DevOps interact, but I work with the data science people a lot, so came up with a few things. One is they just simply want to know where the data is. They want to know what data exists, what's the metadata about it, what's it called, and we can use that. We can use the schemas we've generated, that developers have generated about those logs, and build that glossary of the data that's available. And data science can just go there and say, hey, this is the data that's available at the company, at least that's being captured through this mechanism. That's been really, that's a really great way for data science to know what's available. Also, we've built all these deployment and scheduling and monitoring systems for our web services and other types of services, but they don't use any of that information for, we don't use any of that tooling around scheduled analytics, right? We just run some large set of queries. They run into resource problems just like anything else, and BI people aren't as accustomed to dealing with it, and they don't have the toolkit necessary to understand the problems as well as DevOps can. So we should be using the same tools to monitor our analytics hardware as well. What we should learn from them, good God, all the math stuff. I mean, most of the DevOps kind of is something wrong, looks yeah, that line is bigger than that line, or yeah, they look different. Oh, if you zoom in, they look really different. And so we should be just getting the modeling and sampling techniques from them and bringing them into those discussions. We should be hearing from them about what data streams would really help them, and then, because we know who can create those data streams. What should we be communicating to them? Communicate the outages, communicating when data is different, communicate when hey, that algorithm should not run for that week because it's going to really screw up some personalization thing because the data is half loaded. We should be communicating that upstream. And then obviously what's in the logs, they can browse for it themselves. And then some ideas for them is when data science people are helping write some new algorithm or tweak something and they want to watch some A/B test, they typically pick some indicators about what will make the test successful, it made more money, more people stay on the site, whatever it is. But they only look at a few things they've a priori picked as what they think will be useful. But what would be great is if they could look at all of the data that we're generating about the whole site, all the machine health as well as the more general behavioral health, and say, hey, is my algorithm affecting other things that I hadn't thought about ahead of time? Let's use the same graphing tools and monitoring tools and put those in BI's hands. And if we can also just convince them to help us build predictive models of how many emails Groupon should be sending at 3 p.m., 3:02, and are we way off that would be helpful to us also. Last and probably least, the big shots, everyone wants a hot real-time dashboard, and everybody wants it. And it pained me to build one for our top people because I knew as soon as it looked bad, they would start just going crazy. And they want it, and I was trying to think more about why they want it. And the only way I could think about it is imagine if you you went to go check your own pulse, and you're I'm probably alive. I'll find out tomorrow, right? Even if you can't do anything about it, you want to know the train is on the tracks. You want to know that there's things running through your veins, and just I think them seeing real-time dashboards of money and clicks and activity gives them the confidence that yes, we have a train that's running. I'm going to go and continue my job today. So just the existence of those high-level real-time dashboards goes a long way with these people. Our graphing alerting tools should both use the batch data as well as the streaming. So for example, if you have a streaming outage for a few moments or a few hours, and it's okay, you fix it, no big deal. That wrong data just sits there and just is wrong, on your real-time data screens forever. But the BI team, the next day or next hour, whatever it is, they swoop up the raw data, they aggregate it correctly, they have the right number, right? That's a new true number. That's the number that should be put into the graph at after a day. So the graph should update itself with old data that's from the batch systems that's correct, and then like the last hour is the real-time data as part of the same system. That's really complicated because they have to share the same definitions, but that stuff's hot. And then what should we learn from them? Obviously, like what drives the business, and then this is a huge one. Like if you can take your alerts, like the 80 Nagios alerts, whatever I've gotten during this talk, and order them by money or time or how many people it affects or whatever. Like if you can actually order those things and put like some vector, again, some factor of like this much of this metric down is this X dollars per minute, anything like that, and prioritize your alerts is huge. Like you can just attack the problems by priority. Postmortems, everyone probably does them. If not, they're a great thing to get a weekly postmortem or monthly, depending how many problems you have. But what the best ones I've seen have like a data storytelling angle to them, where it's like it's some Google Doc where it's like problem at X, problem was noticed at X p.m. because of this alert with this graph, and then these people jumped in on the issue. It's more work to do, but if you do data storytelling, like the highest people in your company will be like, listen, like these people are obviously on their shit. Like you can give them this document of, hey, this is like how we notice these things. It wasn't just like Bill talked to John and yeah, it got better later, right? We should be communicating like which metrics mean anything at which granularity, right? Like session data on 3 minutes, like, and depending on your application, is not going to mean anything. So we should be communicating like which data should be used to make decisions. Obviously, we can just, if we keep pushing data up the organization, it'll just make data-driven decisions just obvious, right? You won't even have to say, hey, we should use data. It will just be available. They'll want to rely on it when they're making decisions. And the last one is, back to the point at the very beginning of the talk, where it's like, the better DevOps is, the more silent it becomes. And we should get the company to treat DevOps like, literally like firefighters in the best way. Like firefighters don't assume, no one says that the fire was because of the firefighters, right? Fires happen, and firefighters are good at, they should be evaluating themselves about how quickly do they know about the fire, how efficiently can they put it out, like how safe was it, what was the impact, and like are we ready to do a better job next time? And we should find ways to get the rest of the company to understand like that's how we evaluate ourselves, and like getting down to better performance in that area is like an effort that goes towards silence. So we should reward it and celebrate it. And lastly, so 8 people asked me this already. Groupon has like 500 people in California, like most of which are in Palo Alto, like 100 of which are here, and it's all engineering and data and product and all that fun stuff. All the sales stuff is in Chicago. So if you're interested in any of this stuff and local commerce in general, super hiring, all that good fun. Any questions is awesome. Yeah?
So I'd love to pick your ear. I have a lot of questions about some of your points, but you go on about DevOps being sort of a limited resource. But then you go on, and a lot of this seems to explain really sort of creating your own infrastructure from scratch, designing it around processing tools and other things. I mean, more obviously, the more user-friendly you make something, the more easy you make something for a user, the more work you have to put in the background to make that work right.
Yeah.
So I take it you haven't found any solutions out there that really provide you a framework to work within your data, and that rather you're sort of creating that framework on top of your data and then creating a framework or creating a schema for your data as well, instead of working with existing solutions.
Well, we heavily use some existing solutions. We have like a pretty large Splunk thing going, which I found to be a great way to give everyone in the company who at least has like general scripting or query knowledge access to the raw logs, but it doesn't solve like the data discovery problem. It doesn't solve like what is actually in the logs. And to do that, I feel like you have to go to the source of the creation of the data, which is the people who are logging it themselves. Now, like if you're using Google Analytics or some other piece that knows specifically about what it's logging and it's already pre-structured, then like that's great, it's doing it. But at least so far, we found that at least as the company grows and what's being logged is more custom, then we've needed these like smaller hacks in order to communicate what's actually happening.
There's definitely a widespread of tools out there to feed a lot of different siloed views. it's a conversational.
Yeah, it sounds awesome. I would be super happy not to have to do this. Yeah.
So the way that most of the time we were using DevOps, it sounded like developer and operations, as opposed to the culture that is collaboration and the extension of that to the full company. Can you comment on how the cultural aspect of what DevOps is about applies to it? Is there a sense that one has a blameless culture, as in other companies, where if something goes wrong, they don't like point to the devs and the ops because they are DevOps, and they look at the greater picture of what happened.
No, I think that the best cultures have the collaboration to it, and I think that a lot of thought and organizational energy has been put into bringing these together and getting both people who are interested in operations and people who are interested in just pure development to understand like how code is actually running in the wild and why that's important for actually building it and understanding how it actually works. But I think at least from my perspective, I've seen that there are these natural barriers that tend to isolate them, and the best companies have things that put them together. And I just want to try to find a way that we can use the data that's being generated and make it easier for people to work with each other around the data. So my experience is less in the the nitty-gritty of what's being. The DevOps is actually the responsibility of pushing the code, and more about like the monitoring side and how to use the monitoring data to be available for everyone else. Like the best companies will have people who care about the holistic picture and work together on it. Let's have our tools have the same holistic picture.